Welcome to my racetrack. Now, you might not have any intention of building a racetrack in Factorio, and that is fair enough. I am an eccentric engineer, and these things are of interest to me, and they might not necessarily be any interest to you. The circuit networks in the racetrack, however, are a little different, or at least they might be. I might have built them specifically for the racetrack, but that does not mean that this is their only application. If I've learned anything from this YouTubing experience, it is that we all build our factories to achieve different things, and anticipating the challenges you are going to face is practically impossible. What I can do, however, is go through the interesting challenges I faced and hope that maybe there is some crossover purpose that will suit your application. My normal approach at this point is to tackle the easy things first and get progressively more difficult from there. I want to ease you in, but that isn't really possible with this topic because none of this is easy. If there are any easy elements, then they are dependent on other, more complicated kinds of circuit networks in order to make them function. These topics I'm going to cover in this video are definitely on the more advanced side. In saying that, I'm going to try and cover them in enough detail so that, hopefully, even if you don't understand precisely, you will at least understand their purpose, so that if you came across a challenge where it was applicable, there is a chance this video would come to mind. That is the plan. And as always, I'll be pretty active in the comments if you have any questions or if things need clarification. With all that said, let's get into it. This racetrack has 7 different layouts, with gates that are programmed to open and close depending on which track layout has been selected in this control panel. The problem I have is that I only have access to an on-off switch to control this. That switch can only be controlled by the player. We can't control its value via the circuit network. We can't program it to deactivate when another switch is activated. The issue with regards to this racetrack is that it is possible for more than one switch to be activated at the same time, so 2 layouts open or more at the same time. It is completely impossible to program the gates for this scenario. What I need is some kind of error detection. I need a method for looking at the other values of the switches and determining whether more than one switch has been switched on. Enter my map. These are the 7 different tracks. For each track, and by extension the switch controlling it, I'm going to apply a value. I'm using the variable n for this, so that when combined or added together, this n value can be examined and we can determine whether more than one switch has been activated. The values of n are indicated in the top corner. This system is such that when any 2 or more are combined, i.e. when 2 or more switches are activated, the respective values for n for each individual switch will never be returned. If we take n equals 16 for example, and add up all the values of n below this, so 1 plus 2 plus 4 plus 8, then we get 15. In this way, if the combined value of n of all the switches added together equals any of the values indicated on this map, then we know that only one switch has been activated. This is the check. In practice, what this means is that we have a separate circuit network using the red wires for each track layout switch clump of combinators, all sharing this value of n between them on the green network. Then we need an arithmetic combinator that multiplies the tick value from the switch by the n value on the map, which will be different for each of these clumps of combinators, and then another which checks whether or not the combined value of n equals the n value required for that particular layout. If it doesn't equal 16 from our earlier example, then we know that more than one switch has been selected other than the one for track 5. And because this is a user controlled problem, i.e. the issue is the user activating more than one switch at the same time, the cue that something is wrong has to be visual. Well, I suppose audio would work also. So I've set up these lights to indicate whether everything is hunky-dory. If n equals 16, then I return a green colour. If n doesn't equal 16, then I return a red colour. Then in the lights themselves, I simply set them to use colours and be on when that tick value is equal to 1, i.e. when the switch has been activated. What we have now is a system that will self-detect whether more than one switch has been activated and then indicate that to the user. But that is all it does, and we need it to do more. We need it to control the gates. If we go back to my map from earlier, I have indicated each individual gate location. There are 10 gates, labelled 0 through 9, And my intention is to use the numeric characters in the circuit networks to control each gate. So if character 5 equals 0 in value, then I want gate 5 closed. And if character 5 equals 1, then I want that gate open. I have also indicated on the map, next to the gates, the values of n for when I want each individual gate open. So for gate 5, for example, it needs to be open when n equals 8 and when n equals 64. The end result of all of this is that in order to control the gates, I need a series of combinators to return back these character values tied back to these values of n. To continue with my gate 5 example, I need two combinators, one of which says if n equals 8, then character 5 equals 1, and another that says if n equals 64, then character 5 equals 1. For all other values of n, character 5 will be 0, and thus gate 5 will be closed. If we return back to the control panel in the racetrack, then that is what these combinators are doing. For each indicated gate number, I have a corresponding number of combinators that matches the map from before and opens the gates that are relevant for each layout. Look, none of this is easy to explain. These topics are extremely technical in nature. But what I'm trying to get across, so far at least, is that we have two kinda separate systems in play here. One which is trying to self-detect for errors and make it clear to the user that something is wrong, and another which acts upon that system to do the action the system was designed to do, which is to open and close the relevant gates. There is a third system also. From this control panel, it is difficult to know what each switch is activating or deactivating, so I've made this little map of lights to indicate which parts of the track are switched on or off. It's not to scale, it's not even remotely to scale, but it is a neat little addition to the racetrack concept as a whole. In essence, this is using the logic we have already built into the system with all these gate and n values to light on and off, and then also go red or green to show if more than one switch has been activated. I'm not going to go into detail with this thing. I think I covered lighting arrays more than enough in my previous circuit network video. And besides, if you have come this far and understood most of what I'm talking about, then I'm sure how I made this is obvious. Moving on. Timing. It wouldn't be a racetrack without some kind of timing. At the very least, we need something that can control the start sequence. More on this in a bit. And for this we need what I call the timing combinator. It is actually called the improved combinator. It's a mod you'd need to download. This combinator seems to have an incredible amount of functionality. It would appear that it can do many different things, and I don't know how to use any of them. I don't even really know how to use it to time stuff, even though that is kind of what I've got it to do. I spent a lot of time blindly putting values into this thing. I stumbled across a system that worked, and I kind of just stopped there. If I get a system to work, why go any further? I don't know how or why it works, but it does. So, this is how I have it set up. I'm just going to put the images on the screen because I'm writing this script and I can't remember what the important values are. I never remember what they are. This is impossible. I copied this whole timing thing directly from my reverse racetrack because it was a complete pain to set it up first time around. The trigger mechanism is quite straightforward. It does exactly what you think it should do. You feed it the signal you specify and it will start. In this case, y equals 2 for reasons. The next tab, this is the bit where I don't know anything. I have s equals s plus 1 in here because it works. You start the timer with the trigger and it outputs the time in milliseconds as a value of s. We obviously need to do further processing on this value. A lap time in milliseconds is pointless, but for the purposes of getting any timing at all, this is how I achieve it. Now, to explain how to convert this value of time in milliseconds into a usable time in minutes and seconds, I need to move over to my sketchbook. So the key to this is the way that Factorio deals with numbers beyond a decimal point. So if we do a calculation in Factorio that results in an answer that has a decimal point value, then Factorio will just ignore the decimal point value and round it down to the whole number that's below it. So just to do a quick example, if we say in Factorio did 299 divided by 100. Now in the real world, that would be 2.99. But in the world of Factorio, it would round it down, so that becomes 2. And this is the key way that we can use, this is the mechanism that we're going to use to separate this time value in milliseconds out into minutes, seconds, and milliseconds. So in a similar sort of way, if we take a new number, let's say we've got a value of, I don't know, 8,482 in milliseconds, and we want to convert that into minutes, seconds, and milliseconds using this kind of strategy. So what we're first going to do is we're going to divide this by 60. So 8482 divided by 60 is 141.37. Now in Factorio terms, if we did that calculation, it would be 141. So it would round it down. So if we then take this 141 and times it by 60, we get 8460. So this is a whole number. This is completely divisible by 60. So this is 141 seconds. Anything that's left over when we minus this from this is the milliseconds. So that's what I'm going to do. I'm going to divide minus this first number, the original number, the total number of milliseconds. We're going to divide this. We're going to take away this 8460, and what we're going to have is 22. So that's the number of milliseconds that we have left over. So that's one value that we're going to keep behind. Then we need to find out the number of seconds. So we've got this 141, so we're going to do the same again. We're going to take 141, we divide it by 60, and we get 2.35. Now Factorio says that that's actually 2. So that's the number of minutes. So 2 times 60 is 120, and then we want to minus 141 from this 120. So 141 minus 120, and that gives us 21 seconds. So that's our second number. And then our third number we've already got. We've got this 2. That's our number of minutes. So if we said, for example, we put this in Factorio into the circuit networks, and we said that this is equal to R, this is equal to S, and this is equal to T, and we had, say, 3 digits, and what I use is I've got these little screens which show a value on the circuit network. So I put 3 screens next to each other. I tell the first one that its value is T, second one is S, and the third one is R. And that's how we get the minutes, seconds, and milliseconds, which will be 2, 21, 22. So 8482 milliseconds equals 2 minutes, 21 seconds, 22 milliseconds. And that's what I do to calculate. And I've got a set of combinators in Factorio. In fact, let's go straight back to Factorio and go through this. Back into the world of Factorio, and more specifically the Racetrack, we have this timer section in the control panel with a whole bundle of combinators. These combinators are carrying out the calculations I just went through. A quick thing to note, when the user hits the go switch, there is a 15-second countdown before the race begins. This countdown is made up of 2 stages. First, we have a 10-second gap to allow the user who flipped the switch to make it to their vehicle and still compete in the race. And then we have a 5-second start sequence with lighting and sounds and whatnot. I'll get to this in a moment. So the timing combinator outputs total time since the switch was pressed as variable t, and then we deduct the countdown time from that to get the total time that has passed since the race begun, which is really all we're interested in, as variable s. We then conduct the mathematical process I just went through on value s to separate the minutes from the seconds and the milliseconds. That is what this set of combinators is doing. If we go through them, we can follow the arithmetic. So first we divide s by 60. I forgot to mention this while I was at the sketchbook, but in Factorio there are 60 milliseconds to the second. So we divide s by 60 to get a value, in this instance character 0. These timing combinators are only on the local red circuit network, not the global green network, where, as I previously mentioned, I use character 0 to control gate 0. So then I take that value and I times it by 60 to get another value, and then I deduct the one from the other to get the number of milliseconds, in exactly the same way that I went through in the calculations. In much the same way, these next few combinators carry out the rest of the mathematics. I am more than happy to make the blueprint for this timer setup available to you if you don't want to go through all of this. It is a pain, but it will probably need some modifications depending on what purpose you want it for. The countdown part of the timer might not be so useful to your purposes as it is for a racetrack. I am happy to make changes to it. Anyway, based on this timer setup, we have two processes built on top. Firstly, we have the start sequence. Now, I'm a Formula 1 nerd, so starting sequence for me is 5 red lights that turn on one at a time at 1 second intervals, then all 5 turn green to indicate the start of the race. And because we won't all be able to see any particular starting sequence that I decide to build, we are in 2D looking directly down, centered on our Factorio engineer dude person, not down the line of the racetrack. So I've built an individual lighting sequence for each starting spot on the grid. This is made possible with another mod for inlaid lamps, which allows us to drive over those lamps. So lamp 1 is set to come on at minus 300 milliseconds, which is 5 seconds before the race begins. Lamp 2 is set to come on at minus 240 milliseconds. Lamp 3 minus 180, and so on. And I have a couple of combinators in the control panel that output green or red colour signals depending on whether the race is underway or not. So depending on whether the character value S is greater than 0 or not. That covers the lamps and the colours. The last thing the starting sequence needs is some sounds. I went for the square sound simply because it sounds most like Mario Kart, and then for note C3 for red signal starting sequence and C4 for the go sound, with the same timing as that for the starting lamps. Bosh! Instant starting sequence. Let's give it a go. You'll also notice I've placed down gates for each starting spot which open the moment the race begins to prevent false starts. Now, we wouldn't want any cheating now, would we? The second system I've built into the timer is for some flashing lights. If we think about the mathematics that I just programmed into the combinators, fundamentally what we have achieved is a system where a character increases in value at 1 second intervals up to a maximum of 59, whereby it immediately goes back to 0 again. What if we could change that? What if we could achieve a system where a character increases in value from 1 to 4 and back to 0 at intervals we can dictate, say 10 milliseconds? If we could do that, then we could set a series of lights to come on when that character achieved each of these values and give the impression of moving lights. Let me show you what I mean before I explain how to do it. So 5 lights coming on at 10 millisecond intervals. For all intents and purposes, a single second is now 10 milliseconds and a minute is now 50 milliseconds. So we do the same maths we did before, just by changing those values. Total time divided by 50 gives us a value in multiples of 50 milliseconds with no decimals. We then times that value with no decimals by 50, then we deduct one from the other, and that outputs a character which increases in value from 0 through to 49 at 1 millisecond intervals. We then divide this final number by 10, and bingo, a value of L which goes 0, 1, 2, 3, 4 back to 0 again at 10 millisecond intervals, and thus we have our flashing lights. I do really like my lighting arrays, I'm not going to lie. The last circuit network I've built is kind of a status panel. It tries to show the end results of all these individual networks in one place so that we know what the logic is doing. We have a light which indicates whether there are any errors in the layout switches, whether more than one track switch has been activated. Incidentally, I have the logic set so that the race won't start if more than one switch has been turned on. That is possible to program. What isn't possible is preventing anyone from changing the switches once the race is underway. Proper mayhem is possible if you do that, and there is nothing I can do to prevent it. User beware. Then we have some lights for the go switch. This just indicates whether it has been activated or not, nothing else. Then some lights to indicate that the countdown has begun, and then some that show that the start sequence has begun, and then some that show that the race is underway. All pretty simple stuff. This is the kind of thing I would usually open the video with, seeing as I think it is the most basic of the topics I've covered here, but it is entirely dependent on everything else. It would have made no sense to start the video with this example. There's just one final topic to cover before I bring this video to a close, and that is the things that I couldn't achieve. So what I wanted to do was I wanted to have the stopwatch, the timer, I wanted to have it stop when someone crossed the finish line, or at least some line in the sand. So it is possible to use the gates when they get activated by someone being close to them. It's possible for them to output a signal, and using that same sort of logic, we could use that signal to stop the timer if the timer had that sort of functionality. As far as I can tell, it doesn't. The only way to stop the timer is to go into the combinator itself and physically change the length of the timer. There's no way to send a signal to it which will stop it. That's the first problem. I mean, the second problem is that there must be a way, but I don't know how to do it. You need to be able to read the value of the timer and store that value somewhere. Because you want other people to cross the finish line. You don't just want to... I suppose at the end of the day, if you only had the winner's finish time, that wouldn't be the end of the world. But there's still no way to stop the combinator, the timing combinator. That's really the crux of it. So that was something I wanted to add, and I've tried to add it. And I tried to add it in my first racetrack, but it ended up being just completely impossible. Okay, that is it. That is everything I have for you today. My racetrack circuit networks. I hope it's been entertaining. Till next time.